Hello everyone, it's Miss Lindsay here, and today we're going to look at Unit 18.2 on vector arithmetic. And we want to focus on the first half of this unit, which is how do I calculate using vectors and represent the solutions graphically. Now, before we start the lesson, I'd like you to have a go at the first two questions, which is recapping what we did last lesson in Unit 18.1, and then have a go at the three questions below, which is recapping some of the stuff that you've done with Mrs. Stoll on formula and on functions. Okay, pause the video, have a go, and we'll go through the solutions together. If we start by looking at the first question, I've already drawn the grid. We want to translate shape A by the vector 0, 2 and label this new shape B. So I'm going to take a vertice, this one, go 0 across, and I'm going to go 1, 2 up. So the corresponding vertice is there. And I'll then label that shape B. Then says translate shape B by the vector 2, negative 1. So I'm going to go 2 to the right and 1 down. I'm going to stick with the same vertice and go 1, 2, 1 down. Draw a congruent triangle. That means the same shape and size. And label it C. What single translation maps shape A onto C? 1, 2 across and 1 up, so we represent that as a vector 2 and 1. Part B, what single translation maps the shape C onto shape A? So that's going 2 to the left and 1 down. So negative 2, negative 1. What you'll notice is to go from A to C, it's 2, 1, and to go from C back to A, we switch the signs here, so it's negative 2 and negative 1. Which should help us with question 2. The vector 3, negative 2 transforms shape A to shape B. What vector transforms shape B to shape A? So if we're doing the reverse, we just change the signs. So we've gone from 3, negative 2, so we'll change that to negative 3 and positive 2. Question 3. Make U the subject of the formula V squared equals U squared plus 2AS. So I want to make U the subject. First thing I'll do is I want to get rid of this bit here. So I'm going to do the inverse operations and I'm going to take away that term. I'm going to subtract 2AS from both sides. That leaves me with V squared minus 2AS equals U squared. The next thing I'm going to do is I'm going to use inverse operations. The opposite of U squared is square rooting. In order to balance that, I need to do it to both sides. I'm going to square root this side and square root this side, which will give me V squared minus 2AS square rooted equals U. So I've made U the subject, but it's better if we have the subject on this side of the equal sign, and we change it like that. Question 4. We have the function fx equals x squared minus 3. And the first thing we want to do is find f10. All that notation means is that we're substituting 10 into this function. So wherever there's an x, I'm going to write 10 instead. 10 squared is 100. and 100 minus 3 is 97. Part B, same thing, I'm substituting negative 1 here. So negative 1 squared minus 3, negative 1 squared is 1, and 1 taken away 3 is negative 2. Part C is asking me to find the inverse function. That notation there, the f to the negative 1x, means find the inverse function. And the best way to do this is to change the function to y equals x squared minus 3, and to make x the subject. So I'm going to do inverse operations, add 3, and then I'm going to square root both sides. So I've made x the subject. Then what we need to do is we want to write the function in this form, and we change the y to an x. You should have learnt this with Miss Doll already if you're in set 10.1. If you're in set 2, you may be finding this confusing, you may not have learnt this stuff, so just skip on to the next part of the lesson. Okay, the last question. So we have the function fx equals 3x plus 1, and we also have the function gx is equal to x squared. We want to write down an expression for fgx. What that means is we're going to substitute gx into fx. So wherever there's an x in fx, we're going to replace it with gx. fgx equals 3 lots of x squared, because gx is equal to x squared plus 1, which is 3x squared plus 1. Part B is the other way around this time, so we've got gfx. So we're going to substitute fx into gx. So wherever there's an x over here, I'm going to write 3x plus 1. Instead of writing the x, I'm writing 3x plus 1. I need to square that. And then I'm going to multiply out 3x times 3x is 9x squared, 3x times 1 is 3x, 1 times 3x is 3x, and 1 times 1 is 1. So it's 9x squared plus 6x plus 1. The final part of the question, where you've done all of the hard work really, you want to solve fgx is equal to gfx. So we know that fgx is 3x squared plus 1, and gfx is 9x squared plus 6x plus 1. Okay, to solve this, I want to move all the like terms onto the same side, and I'm going to use inverse operations. I want to remove this 3x squared, so I'll subtract that from both sides. I'll end up with 1 equals 6x squared plus 6x plus 1, and I want to subtract the 1, so I'll end up with 0 equals 6x squared plus 6x, or 6x squared plus 6x equals 0. In order to solve this, I need to factorise it first. The highest common factor is 6x, x plus 1. So that means that either 6x is equal to 0 or x plus 1 is equal to 0. So x is equal to 0, or take away 1, x is equal to negative 1. Okay, like I said, if you're in set 1, question 3, 4 and 5 should be a recap of what you've done with this Stoll, and questions 1 and 2 are a recap from our last lesson on vectors. Now, one of the really important pieces of knowledge that you need to know before we continue this lesson are the properties of quadrilaterals. It's something that you should have met in Key Stage 3, Year 7, 8, 9, and maybe in Year 10 as well. What I'd like you to do is I want you to have a look at the shapes that I've shown you here on the screen and write down the names of the shapes. Now that part should be easy for you. And then I want you to think about the properties of the shape. In other words, what is it that tells you that that shape is a rectangle, for example? Pause the video, write down as much as you can about the names of the shapes and their properties, and then play the video and we'll go through them. Okay, so you should should have noticed that the first shape is a rectangle. How do you know that that shape is a rectangle? Well, it has 4 sides, every angle is 90 degrees, and the opposite edges are equal in length. The next shape is a square. It's a special type of rectangle. It has 4 edges, they're all equal length, and it has angles of 90 degrees. The next quadrilateral is a parallelogram. It has 2 pairs of parallel sides, and it has 2 pairs that are equal in length. So this side and this side are parallel and equal in length, and this side are parallel and equal in length. The next one is a rhombus. It's a special type of parallelogram. All 4 of the edges are equal in length. These 2 sides are parallel, and these 2 sides are parallel. Then we have a trapezium. How many parallel sides does a trapezium have? 1 pair of parallel sides. This one and this one. Then next we have an isosceles trapezium, which is a trapezium with 1 pair of parallel sides, and the other 2 edges are the same length. We'll stop there because those are really the only types of quadrilaterals that you need for this lesson. Okay, let's try some examples on what we're learning today then. It follows on nicely from what we've done last lesson. So the first part you should be able to do, and then we'll discuss the next part all together. Just have a read of the question for me. Okay, so the first part of the question is telling us that we've got a quadrilateral. You can see it has 4 vertices, A, B, C, D, and A has coordinates 1, 1. So the most logical thing for us to do is to draw a coordinate grid. And label point A as 1, 1. 1. There's point A. It tells us that vector AB is 1, 2. So from A, if I go 1 along and 1, 2 up, that will give me B. It tells me that vector BC is 4, 1. So from B to C, I'm going 1, 2, 3, 4 to the right and 1 up. And vector CD is 3, negative 1. So I'm going to go 3 to the right and 1 down. 1, 2, 3. And if I join up those points, you can see there that I've got 1 pair of parallel lines. And there I have my quadrilateral. And part B is asking us to write AD as a column vector. So A to D, and then 1, 2, 3, 4, 5, 6, 7, 8 across, and 1, 2 up. So that's 8 and 2. Part C is saying, what type of quadrilateral is ABCD? Now, if you need to, rewind the video and have a look at the types of quadrilaterals that we looked at, and you should be able to tell we've got 1 pair of parallel lines, and that's a trapezium. Part D, what do you notice about BC and AD? So we know that vector BC is 4, 1, and vector AD is 8, 2. AD is 2 lots of BC. 4 times 2 is 8, 1 times 2 is 2. Okay, I'd like you to pause the video, have a go at the question below. I'm going to leave my solution here to this question. It's really quite similar. You may need to look back again to the types of quadrilaterals, So have a go, and then we'll go through it together. Okay, so again I'm going to draw myself a coordinate grid with x and y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. Probably doesn't need to be this big, but just in case. Point A has coordinate 1, 1. Vector AB is 2, 3, so that's 1, 2 to the right and 1, 2, 3 up. That tells me that that's B. And vector AD is equal to 4, negative 1. So from A I'm going 1, 2, 3, 4, minus 1. That gives me B. We don't know the rest of the information, but we know that the shape's a parallelogram. So if I join up my points here, I should have a parallel line here. And if I join up my points here with my ruler, I should have a parallel line here. So point C must be there for that to be a parallelogram. Part B, write as a column vector CB. So to go from C to B, I'm going 1, 2, 3, 4 to the left and 1 up. So that's negative 4 because I'm going left and positive 1 up. And C, oh no, sorry, that was part B1. Part B2, BC is 1, 2, 3, 4 across and 1 down. So 4 to the right and 1 down. What do you notice? Well, I noticed that the vectors are exactly the same, but the signs are switched over. Vectors are the same, but with different signs. So instead of negative 4, we've got 4. Instead of 1, we've got negative 1. For part C, what do you notice about AB and DC? So we know that AB is equal to 2, 3. And DC is equal to 2, 3. Now there's a common theme throughout this lesson. We'll notice that these two are parallel lines and they're the same vectors. We'll look for that pattern a lot during this lesson. So AD is equal to 4 minus 1, which we already know, and CB is equal to minus 4 and 1. What do we notice? They're the same vectors with different signs. A more mathematical way to write this would be that AD is equal to minus 1 times CB. The next key point I want us to look at is on the screen here. Could you just take a moment to read through? Now, we've pretty much just worked that ourselves with the previous two examples. So if AB is equal to CD, then the line segments AB and CD are equal in length and are parallel. If we look back to the previous question here, AB and DC are parallel. They'll be the same vectors as we noted. AB is equal to negative BA. So if you look at this diagram here, they're exactly the same length, but they're going in different directions. So that would be the equivalent to this question to AB and CD, the same length but different directions. Right, let's go through an example. In quadrilateral ABCD, AB is 3, 4, BC is 5, 0, CD is negative 3, negative 4, and DA is negative 5 and 0. What type of quadrilateral is this? Right, so we don't need a coordinate grid this time because we don't know the coordinates of any of the points, but we can start with A here. And we know that A to B is 3, 4. So 1, 2, 3, 1, 2, 3, 4. And we're going from here to here, so that's the direction. We know that BC is 5, 0, so that's 5 to the right and 0 up or down. 1, 2, 3, 4, 5. We know that CD is negative 3, negative 4, so that's 3 left and 4 down. 1, 2, 3, 1, 2, 3, 4. And we know that DA is negative 5, 0, so that's 5 to the left. 1, 2, 3, 4, 5, and that takes us back to A. What type of quadrilateral is ABCD? But well, we can see that there are two pairs of parallel lines, here and here. So that means it's either a parallelogram or a rhombus. And the difference between a parallelogram and a rhombus is a rhombus has all sides the same length. So I can see here that this side length is 5 and this side length is 5. I can't tell this side length, but it looks quite similar. I could measure with a ruler, or if I didn't have a ruler, I could use our rule from last time, or I could use Pythagoras. That's 3, that's 4. So that length there will be 3 squared plus 4 squared, square rooted, which is the square root of 25, which is 5. And this length is also the same. Therefore, this must be a rhombus, not a parallelogram. Okay, pause the video. You tried this question, it's almost exactly the same. I've changed the numbers slightly. So you've got a 2 and a 4, a 6 and a 0, a negative 2 and a negative 4, and a negative 6 and a 0. Okay, hopefully you guys have paused the video and you're ready to go through the answer with me. It's really similar to the last solution which I left on the page there. So we'll start with A, and AB is 2, 4, so 2 to the right, 1, 2, 3, 4 up. BC is 6, 0, so 6 to the right and 0 up or down. 1, 2, 3, 4, 5, 6. CD is negative 2, negative 4, so 2 left, 4 down. 1, 2, 1, 2, 3, 4. And DA is negative 6, 0, 1, 2, 3, 4, 5, 6. 0 up or down. Okay, what type of quadrilateral is ABCD? So we've got two pairs of parallel lines, so again it's either a parallelogram or a rhombus. Now in this case we've got the length here is 6 and the length here is 6. That's 2 and 4. Let's use Pythagoras to just check if that's the same length or not. Square root of 4 squared plus 2 squared, which is the square root of 16 plus 4, which is root 20, which we can simplify, which gives us 2 root 5. So we have this pair that's the same length and parallel, and this pair that's the same length and parallel. So that's a parallelogram. That's 1L. Parallelogram. Yes, just double checking my spelling. 1L. Right, you guys have a go at this question. This is an exam question on vectors. It covers all of the things that you've learnt this lesson and last lesson, so you should be able to do that. Okay, hopefully you guys have had a go. Let's go through the answers together now. So P is the point 0, 3. So we need to draw a coordinate grid for this one, because we have been given a coordinate. Point P is 0, 3. So 0 across and 3 up, that's P. PQ is 2, 3. So 2 to the right and 3 up. 1, 2, 1, 2, 3. First question, nice and easy. Find the coordinates of Q. So Q is 2, 6. Remember, we write coordinates differently to how we write vectors. R is the point 2, 4. Let's mark that on. 2 across, 4 up. QS is a diagonal of the parallelogram PQRS. Express PR as a column vector. Now, this sentence here isn't really relevant to us when we're answering this question here. PR as a column vector is 1, 2 along and 1 up. Part C, calculate the length of PG. We know that RT is 2 and negative 3. 1, 2, 1, 2, 3. So there's T. This is a recap of what we learnt last lesson. Remember, we used Pythagoras, so I'll just draw that in to remind you. 2, 3. If the vector is 2, negative 3, we use Pythagoras and we say 2 squared plus negative 3 squared square rooted, which will give us this length here because it forms a right angle triangle. So that's the square root of 4 plus 9, which is root 13. Okay, hopefully you all got 7 out of 7. If not, no worries. Correct your work and we'll move forward. Okay, there's another key point here. I want you to pause the video and read the key point by yourself. A is twice as long as A and in the same direction. Negative A is the same length as A but in the opposite direction. This should help us with our next example. If you copy the example down, or you don't need to because mine will be on the screen when you're doing your turn anyway. So I have my vector A here, which if you look at the screen you can tell that that vector is 1 to the right and 2 up, so we can say that A is 1, 2. I'm also going to draw it. And I want to draw the vector 4A. If we look back to our key point, 2A is twice as long as A in the same direction. So 4A is going to be 4 times as long as A and in the same direction. The direction represented by this arrow here. An easier way to do this is to look at my vector 1, 2 and multiply it by 4, which gives me 4, 8. start here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. There's my vector 4a. Now the next vector that I'm going to draw is negative. It's going to be in the opposite direction. Or another way to say it is I've got 1, 2, and I'm multiplying by negative 2, so that will give me negative 2, negative 4. I'm going to start here. 1, 2, 1, 2, 3, 4. Now you'll notice that it's still parallel to A, but it's going in a different direction. I started here and I'm going down here. Okay, I'm going to leave my solutions there with the question. Could you guys have a go at your turn, pause the video, try it, and then we'll go through together. Okay, so let's find out what 2a would look like. So if we know that a is 1, 2, for 2a we just multiply that by 2, and we'll get the vector 2, 4, which will look like this. 1, 2, 1, 2, 3, 4. For negative 3a, I'll start with a, which is 1, 2, and I'm going to multiply by negative 3, which will give me 1 times negative 3 is negative 3, 2 times negative 3 is negative 6, negative 3, negative 6. I'll start here. 1, 2, 3, 1, 2, 3, 4, 5, 6. Starting here this time and going in the opposite direction, which we already knew would happen because it's negative, and we're told here in the key points that that means the opposite direction. Okay, a few more questions for you guys to try. Put a heading of try these, have a go at these questions, and then we'll go through the answers together. Okay, I'm not going to draw these vectors out, but I'm going to write that vector A is equal to 2, 3. We can see that that's 2, 3, 1, 2, 1, 2, 3. And vector B starts up here, and we're going 1 to the right, and 1, 2, 3, 4 down. So 2a will be 2, 3 times 2, which is 4, 6. So let's start here. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Part B. You want negative a, which is going to be 2 over 3 times negative 1, which is negative 2, negative 3. Start here. 1, 2, 1, 2, 3. And if you look, it's exactly the same as A, but in the opposite direction. C is negative B, so that's going to be 1, negative 4 times negative 1, which is negative 1 and 4. Start here. Negative, oh no, that won't work. Start here. Negative 1. Actually, better to start down here. Negative 1, 1, 2, 3, 4. Check the diagram, does that look right? Yeah, it looks the same as B, but it's in a different direction. Part D, I want to do 3b, which will be 1, negative 4 multiplied by 3, which is 3, negative 12. I'll start here. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Make sure you put the arrow showing the direction, and we underline, remember from last lesson, to show that it's a vector, negative 3b. Turn the page. E. Here is negative 2b, which will be equal to, what would be? B was 1 minus 4. We're going to times that by negative 2, which will give us negative 2, 8. I'll start here. So 1, 2 to the left. Oh no, that's not going to work because I need to go 8 up. I'm going to start here and go 1, 2 to the left. 1, 2, 3, 4, 5, 6, 7, 8. And that's negative 2b. Question 3 then. So my vector A is equal to 3 across and 1 up. So 3A will be equal to 3 times 3, 1, which is 9, 3. So we'll start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. Negative A will be equal to negative 1 times 3, 1, which is negative 3, negative 1. Start here, 1, 2, 3, 1. So this should be A, but in the opposite direction. Part C, negative 4A. That will be equal to negative 4 multiplied by 3, 1, which is negative 12 over negative 4. Right, so I'm going to have to start all the way over here, because I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4. Negative 4a. And last one, these should be getting pretty easy by now, is 0.5a. In other words, a half a. So that's equal to 1/2 times 3 over 1, which will give us 1.5 over 0.5. I start here, 0.5, 1, 1.5. So, teeny little vector, 0.5a. Okay, great work everyone. Moving forward, that sort of leads us on to the next point. We've really worked out the next point already, so I hope. When a vector A is multiplied by a scalar k, then the vector ka is parallel to A. So if you look back to all the previous questions that we've just done, you should be able to see that. A scalar is just a number, so 3, 2, a half, minus 1, a third, 2/3, 1.1, all of those are scalars. So let's decide if these are parallel or not. Is A parallel to 2A? Yes, they're parallel. The scalar would be 2. Is A parallel to negative A? Yes, they're parallel. The scalar would be negative 1. Is A parallel to negative 0.5A? Yes, they're parallel. What would the scalar be? Negative 1/2. Is A parallel to B? No, if we look back up some of our previous questions where we've got two different vectors, A and B. Might have to turn back the slides here. So here, A and B, no, they're not parallel, are they? A and A plus B, no, they're not parallel. We haven't multiplied by a scalar, we've just added on a different vector. A and 2A plus B, not parallel. We haven't multiplied A by a number, we've added on a completely different vector. And when we have multiplied it by 2, if it was just 2A, it would be parallel, but adding the B makes it not. Yes, this is parallel, the scalar is -2. No, not parallel. Okay, for the last part of the lesson, I'd like you to answer question 4 and 5, please. Pause the video, then we'll go through the answers together. Okay, question 4. AB is 2, 1. Copy and complete to find the column vector for 2AB. So what do you think 2AB is then? It's just 2 multiplied by AB. So 2AB is equal to 2 times 2, 1, which is 2 times 2 over 2 times 1, which gives us the vector 4, 2. Part B1, write down the column vector for 3AB. Well, I'm just going to multiply AB by 3, so that will give me 6 over 3. Negative 4AB. Well, I'm going to multiply AB by -4, which will give me -8 over -4. Part 3, 1/2 AB. Well, I'm going to multiply AB by 1/2. Half of 2 is 1, half of 1 is 1/2, or 0.5, either of those will be correct. Question 5. If AB equals 1, 2, and BC equals 3, 1, write down the vector AC. Probably the best thing to do here is draw it. That's already been done for us. A is 1 across and 2 up. BC is 3 across and 1 up. What's the vector AC? We can tell from the diagram. 1, 2, 3, 4 to the right, and 1, 2, 3 up. Is there an alternate way to do that apart from counting the squares, do you think? How else can we find AB to BC? Okay, some of you hopefully worked out. You can just do AB plus BC, which is 1 over 2 plus 3 over 1, which gives us the same answer, 4 over 3. That leads us into nicely what we're doing next lesson. Okay, well done for all your hard work, and I'll see you next lesson.